In Module 3, Lesson 13, we're going to continue looking at inequalities. Tariq is trying to save $265.49 to buy a new tablet. Right now he has $40 and can save $38 a week from his allowance. We're going to write and evaluate an expression to represent the amount of money that's saved after 2, 3, 4, 5, and 6, 7, and 8 weeks. So to start off, at the 2-week mark, he has $40 plus 2 times 38, which means he has 40 plus 76, or $116. At 3 weeks, he has 40 plus 3 times 38, and after we complete all of the numerical expressions, we find a total at 8 weeks of $344. The question that they then ask us is, when will Tariq have enough money to buy the tablet? He needed 265. So at 6 weeks, and beyond, Tariq will have enough money. Writing an inequality that generalizes the problem, we would say 38 times the number of weeks plus 40 needs to be greater than or equal to 265.49. In other words, if he had exactly $265.49, he could get it. But if he has more, he can also get it. Greater than or equal to that amount. Now let's set sum up. The sum of 2 consecutive odd integers is more than negative 12. So the first thing we'll do is to list some numerical inequality expressions that work. Remember, 2 consecutive odd integers means that it is 2 odd numbers when added that are right next to each other if we listed all of the odd integers. So picking some at random, 5 plus 7. Both of them are odd and they are right next to each other if I were to list all the odd integers. 5 plus 7 is greater than 12, or negative 12. Kind of obvious. We could say negative 3 plus negative 5 is greater than negative 12, because negative 3 plus negative 5 is negative 8, which is greater than negative 12. We could say zero plus negative 1 is greater than negative 12, and so on. There are an infinite number of consecutive odd integers that we could add together with the that are greater than negative 12. So what we want to do then is to write an inequality that will find all the values that make the inequality true. As well as the smallest value. So let's scan down here. If the sum of two consecutive odd integers is more than negative 12, what is the smallest value that will make this true? So we're going to look at, first of all, setting up the integers. If we choose x, let's choose n, to be an integer, then n plus 2 correction, 2x plus 1 would be an odd integer. Because if we double something, if we double any number, it would be even. And then if we add 1 to it, it will definitely be an odd integer. And then it follows that the next odd integer would have to be 2x plus 3, because the next odd integer up from that would be 2 away. And then taking that, oh, we were using n, weren't we? Let's switch this to n. And then taking what we know about odd integers, we would now say 2n plus 1 plus 2n plus 3 needs to have a value greater than negative 12. And we're going to then combine like terms, giving us 4n plus 4 is greater than negative 12. Now, using if-then moves is really just solving this equation, or this inequality, in the same way that we've solved equations. So if this part is greater than b, or this part, then we can add, subtract, multiply, or divide from both sides the same number, and it would still preserve the value of the expression. That means that what we can do is 4n plus 4 minus 4. We're going to subtract 4 from both sides, is greater than negative 12 minus 4. In other words, if a is greater than b, then a minus 4 is also greater than b minus 4. And that will give us 4n plus 0 is greater than negative 16. And that is simply There's the identity property, 4n plus 0 is 4n. But we won't write every step now. We've been practicing this for a while. Now what we're going to do, in order to have n by itself, is we're going to multiply by the reciprocal. Well, we're going to divide by 4, but that means multiplying by the reciprocal, which is 1/4. And 1/4 times 4n will be greater than negative 16, or 1/4 times negative 16. And again, we're really saying if A is greater than B, then A times 1/4 is also greater than B times 1/4. And it follows then that this would be 1n, or n, is greater than negative 4. It's 1/4 times negative 16 is negative 4. So the values then that will make our original statement true are when n, or the integer, is greater than negative 4. Meaning it could be negative 3, negative 1, or all the values beyond that. To practice, we're just going to look at a couple of exercises. The first one, Connor went to the county fair with $22.50 in his pocket. He bought a hot dog and a drink for $3.75, and then wanted to spend the rest of his money on ride tickets, which cost $1.25 each. They want us to write an inequality to represent the total spent, where R is the number of tickets purchased. So what we know then is that he spent $3.75 for the hot dog and the drink, and that is gone. The rest of his money, which is $1.25 times R. And we're looking for R. Now this amount has to be less than or equal to $22.50 because that's all he has in his pocket. So here's our inequality. Now Connor wants to use this inequality to determine whether he can purchase 10 tickets. So we're going to use substitution to show whether or not he'll have enough money. We'll rewrite our inequality, 375 plus 125 times 10. And then determine whether that is actually less than or equal to 2250 or not. So we do our math, 375 plus 1250, which is 125 times 10. And we need that to be less than or equal to 2250. And when we add those numbers together, we find that the total is 1625. And we check to see if that's a true statement. Is $16.25 less than or equal to $22.50? And yes, it is. So he will have enough money to get 10 tickets. Finally, we're asked what is the total maximum number of tickets he can buy. And so in this case, what we really want to do is solve our inequality. And when we complete our math, and our final problem deals with checked bags. Checked bags can weigh no more than 50 pounds. So if Sally packed 32 pounds of clothes and 5 identical gifts in a suitcase that weigh 8 pounds, we'll need to write an inequality to make sure that she does not go over the 50-pound limit. And so our inequality is 32 plus 5 times the gift plus 8 pounds for the suitcase, because the suitcase is weighing 8 pounds. And that all must be less than or equal to 50. We'll combine our like terms, which will give us 40 plus 5g, which needs to be less than or equal to 50. And then subtracting 40 from both sides. And finally dividing by 5, we find that each gift can be no more than 2 pounds.